and inviting me along. I understand I'm a substitute, so I'll do my absolute best. And, thank you, Sarah. So I'm going to talk to you today about Newbridge Woods, so applicable to the west of England because this is Bodmin, Cornwall. So we're going to talk about the debris flow that occurred back in 2018, and we're going to then talk about the unlocated culvert that led us to find the particular issue. So there should be time at the end for questions. Take them at the end, that would be great. If you've got anything burning or pressing, then just let me know. Gary, am I in the camera still?
Yeah.
That's good, excellent. So in terms of some of the background, so it's always important to think about the background to any particular problem or site. So back in November 2018, we had a pretty wet period of winter, so we had some rainfall that occurred. As it says there on the slides, 212 mil monthly total, so that's a fairly significant amount of rain, especially for Cornwall, where you've got very little ground cover in terms of the overlying soil. So 212 mil, went back to the drawing board in terms of we went back to basics and worked out the return period. So the 1 in 65-year event was what we'd ended up with. So quite a lot of rainfall in a very short period of time. As it says there at the bottom, we did go to site post the incident. So we had a 5-mile-an-hour speed restriction on, debris onto the track, flooding as well, so caused the line to be closed for a short period of time. And just in terms of some of the background, we engaged Balfour BT to undertake the remedial work, so clearing up the site, moving some of the spoil, and then as it says, I'll go into the background of the site, go into the topography, the geology, also the hydrology as well, and just talk a little bit about asset management sort of towards the end. But hopefully it'll be an interesting run through of what happened back in 2018. So as you can see here, I'll draw your attention to this pipe. You can see the very small opening in the pipe. That's a culvert under the track. 300 mil pipe in this instance is at the inlet, so ground on this side of the railway, which is the downside, it's higher, passes beneath the railway on embankment here, sidelong ground, and discharges to the River Foy on the opposite side of the railway. So what you can't see there is the A38, which is the public highway adjacent to the railway here. You'll see it in a couple of slides later on, but setting the context, just east of Bodmin Parkway Station, so on the Cornish main line, and forestry above the railway. So fairly rural. One development, which is a source of contention still, so I can't be too specific, but we certainly have a less than friendly landowner on this side of the railway, which is the downside. So that's what it looks like today, even though that picture was taken in 2018. That's what it looks like today in terms of the site setup. So culvert in that, you'll note this large area of exposed ground, open ground, and that's of relevance. So just remember that image in your mind. This is what happened. So 2018, November the 12th, track flooding, and that culvert's been overwhelmed. So the culvert that I've shown on the previous slide is about here. And again, same sort of area about here. So culvert's been overwhelmed, and in the first instance, you would have thought we'd known about that culvert. It was recorded. You would have thought we'd known the diameter, the size, the condition. None of those things were known. So at this point, back in 2018, this was a fairly tense time for me, looking at this kind of reporting back from control and from the local operations guys. This wasn't in our asset register, so it wasn't in the LIPS. It wasn't held anywhere that we could readily get our hands on the information. So that was the first thing, was to determine what was there. But 212 mil of rainfall looks something like that. The blue pipe, for those who are interested, is something that the landowner managed to install without permission. So you can see it's not really well founded on the underlying strata. So that was the other big risk, that pipe was going to roll towards the track. So that was the first thing we had to do, is take that pipe a lot of water. These pictures were taken during the immediate aftermath of the event, so removing debris. You'll recognise this large channel or hole on the end of the culvert, so culvert head wall here. Just to give you a bit of reference, I shall skip back in the slide and just compare that area. So that's what it looks like when it's lovely and sunny. That's what it looks like when it rains. So there is a large amount of water that's making its way through that culvert. Always has done. It's just that we have not collectively understood the asset. We've not recorded it, as I said. So you can just about see the top of the pipe here, the water disappearing into the hole. So, yeah, a lot of water. Now, in terms of the event, the bad thing had happened. We'd acknowledged that we had a risk. The culvert was unlocated. We'd had debris flow. So the next stage of the process was to actually understand some of the site background, the context. So this was probably the most important part of what we did in terms of the desk study, and it's an important part of any investigation. So the red star is the location of that culvert and the debris flow. You can see different geologies. So you've got very clearly here an alluvium type material. So that's the River Foy, that's the river valley. So the ground here slopes, and you'll see it in the other slides, I promise, towards the railway here. So this is the downside of the railway on the bottom of the screen, and then the upside, so that's to the north, this is to the south. And you can see very clearly different geologies. So you've got slate and you've got sandstone. So sandstone at the top, a generally fine-grained material, so lots of potential for sediment to be produced. And then you've got down into here the slate and the siltstone, so a little less able to generate fines, but still potential for lots of sediment. And as you'll see in the previous slide, this material here is all the siltstone, the slate, a bit of sandstone that's washed from the upstream catchment down towards the railway. So when we say debris flow, that's exactly what I mean. You can see the amount of material that we've had to locally move on site to get a safe railway operating again. So it's important to understand that context. In terms of topography, so we talked about geology. That's important to understand what's underlying the site, always. Topography, so we had WSP, and thanks to Will Johnson, who is leading the flood team in Exeter in their office there. You can see here these channels, these incised channels. So the blue arrows there just indicate the path of least resistance for water. So incised channels. The site location is this red triangle in this case, or the culvert on the quay. And again, you can start to see different colours are different heights above Ordnance Datum. So the reddy coloured hue is higher ground, and the blue is the lower lying land. The river here is this feature. I'm hoping that you can see that on the video as well. The development I talked about is this red line boundary here. So this is a private property, residential, with some caravans placed on it. I can't say too much about that. We're still in dispute with the landowner, but needless to say, it's having an impact on our railway. That gives you an idea that the site is quite steeply graded towards the railway. We can ignore this one for now, because we're talking about this particular feature. There we go. So this is the 3D version. I thought this was quite cool, but I'm a sad drainage engineer, so I would think this is cool. But you can see the LiDAR mapping that we did. So we had a drone up. Even in 2018, we're starting to explore the use of drones. And you can see this is the 3D version of the previous slide. So incised channel here, really good at picking up the wooded feature. So you can see where there's been some deforestation at some point. So this is used as agricultural land now and cultivated, but you can see the channel coming down. You've got the development, and then you've got the culvert here. So we remember that we talked about the A38, which is this road at a slightly lower level down here, and then the river. So it just helps to visualise for those not necessarily aware of the whole background of the scheme to see there's a lot of potential for water and for debris to run down here. So hopefully it's clear to see that culverts are needed. We didn't know about that one. We didn't know about that one either. So a lot of this has been about doing a proper desk study, even if it is retrospectively. Because I like to draw, I thought this was quite useful. So produced for another meeting and another purpose, but it gives you an idea of the cross section of what we're looking at. So 70 metres above Walnut Datum on the left, under the railway in a culvert. So definitely two sections to this culvert. There's a pipe section, which is the one we've been talking about. It's sort of up here at the inlet. Box, or 450 box culvert as it says there, under the railway. And then we're into this box section here as well. So out to the river Foy, so 27 metres above Walnut Datum. So you can see quite a difference in elevation there, and the potential therefore for debris and for water to find its way to the railway, which is at about 39 metres above Walnut Datum, is quite significant. So that just gives you an overview of the site, and it's never a bad idea as an engineer to do a little hand sketch. So we've got the best of both worlds here. In terms of the catchment, so we talked about geology, talked about topography, combined into then the surface water catchment. So using the same data, so we use the same data set twice, which is good, and get your value for money from your data. You can see straight away that this all feeds down towards the culvert. Kind of area that we have at the top of the catchment, open fields. If you recall from the 3D image that we had up, open fields, definitely cultivated. You can see the tram lines here and the seedlings growing up. The water's finding its way towards the railway and trying to re-establish where it wants to go. Water will always find the path of least resistance. You can see at the line at the top of the catchment, the headwaters effectively, water is funneling down towards the railway. So that's this image. As you get further down into the catchment and further downstream, you get into this very steeply wooded section. So again, predominated by trees, a very narrow channel, very well defined, quite in size, again, heading towards the railway. So all of the key things about drainage, flood risk are here. We've got a big catchment upstream, we've got a really well defined channel. So when we say unlocated culvert, and it's in the title of the presentation, it's just that we haven't acknowledged it's there. All of these things, even if you didn't know about the asset records that we hold or the structures register that we have, it's pretty clear to see that if you follow that line down, you would expect the culvert to be there. Adjacent land use, again, is really important. So we talked earlier about the development that's happened. When I say development, it's a little bit of a loose term. Caravan, as I referred to, N-tip material, not great for slope stability. So all of that material is loose, all of that's N-tip. Some of that is what ended up on the railway. So again, so I can't say too much, but we do have an ongoing legal case with the landowner. So important to understand adjacent land use. Just to give you an idea that it isn't just me and it didn't just appear. That's what it looked like when I turned up in, whenever it was, the end of November 2018. That's all you could see of the culvert. You could not see anything else. Track ballast is just up here in the top right of the left-hand picture. So headwall's just visible there. It was at that point that I thought I probably needed to get some help. I got about that far down and went, I probably should give up now. So bigger machine came in and found the culvert. But for those eagle-eyed amongst you, you'll notice that the pipe is discharging to the old stone headwall. So it's this pipe section that's probably caused us the biggest issue. The actual culvert beneath the track is relatively okay. It's just this pipe that's caused us the biggest issue. So under the track, again, decades of root mass in here. So this is the culvert beneath the railway. So 450 width, roughly 450 height. Difficult to dimension a stone culvert because if you take the measurement here to here, you've got a different one. So if you take it there, there. But broadly, 450 by 450. Root mass everywhere. So this is, I think, before the cleaning or during the cleaning. You'll see as we go through, more of the root mass is exposed. You can start to see more of the shape of the culvert there. But this is decades worth of debris, decades worth of material that's ended up in that culvert. Nearly clean, so very nearly clean as far as possible. Slightly worrying call from the guys on site saying, do you want us to stop jetting because the railway is shaking? These are all, and there's a lot of them in Cornwall and Devon, these are all open dry stone type constructions, so there's no mortar in any of the joints. They are all open, which is what allows the root ingress in. This is really quite a telling picture. So the outlet of the culvert, bottom of the road embankment, see the shape, clearly see the water. All of this material had built up all the way around the end of the culvert. So there was no chance that culvert was ever going to work in its pre-condition. So unlocated culverts are therefore a huge issue for me, they're a huge issue for the business. That amount of water was previously finding its way through the formation, onto the highway, to the ground. It should be going into that culvert. So the bad thing has happened. We'd ended up with the flooding, we'd ended up with the 5 mile an hour TSR. We cleared up the debris, you can see some of it just here. Some of the material P-way helped us to move. That's all of this detritus in the trench. So this is now coming on into the remediation side. So we found the culvert, we got it working. We now thought, right, we'd better do something about it. So a few images here from some of the feasibility work that we did. So catchment study was done, we talked about topography, we talked about geology. So we're now at the point where we are today, which is looking at remediating that culvert. So stone box culvert, full of roots, not great condition, end of the asset's life probably, I would argue. So therefore we've taken forward the approach of we need to find a replacement culvert. Can't really dig up the track here. It's a fairly substantial dig, and also you'll note from this lorry here that there's a fairly significant height difference between the railway and the road, that any open cut excavation would probably be quite intrusive. The A38, for those who go on holiday to Cornwall, is a very, very, very busy road, especially from pretty much now to the end of September, October. So no chance of doing the work in the dry period when we'd like to do it. And it's not a good idea to be working in water or near a river in the winter. So that's where we are now. That's what it looks like today. It's greened up a little bit. Not a great look, but it is functional and it is safe. In terms of the site context now, looking downstream, this is on the A38 embankment. So we've got a nice speed restriction on there, but you can see here the channel that we've had to excavate for the culvert. Again, culvert passes beneath the road there, so just demonstrating there the difference in height. And then ground investigation. So I always like to take the opportunity to talk about ground engineering and specifying it, because specifying it is critical. If we specify ground engineering, we have to pay for it, which is fine. It's a cost worth bearing. Having been involved with projects before where we skipped the ground investigation or skipped the SI, site investigation, and we've done it in the later stages, you pay for ground investigation whether you specify it or not. So definitely, ground investigation for me, personally, over my career has been my big drive, because it's not actually that much cost in the grand scheme of things. And for example here, WSP have managed to extract from National Highways, or Highways England, whatever they're called now, all of their borehole records and all of the geology information. So we didn't have to pay for a great deal of it. So that was the point I was going to make there, that actually when we looked at this and we started to specify the GI, we found that we probably only need 1 or 2 holes this side of the railway. We've got the rest here to build up a good ground model. So specify ground engineering, please, or ground investigation. So the need for ecology. So everybody talks about ecology. everybody thinks it's difficult and it's a constraint and it's a headwind that comes up at the last minute. For us, nothing could be further from the truth at Newbridge Woods. So from the start in 2018, one of the first things we did was generate a preliminary ecological appraisal. I can never get that right, but a PEA to the rest of us. So that looks at the potential for habitat to be there, so dormouse, water voles, especially on the river. So this is so critical and so important. And doing it at the front end of the programme, as we've done it in this case, I estimate it's probably saved us months and months and months of time. We still have to do the surveys, you still have to do all of the licences with Natural England, you still have to get in place your permits, but doing it at this end of the programme, as opposed to after the AFC, for example, which is typical, can be a game changer. And I just wanted to share amongst the professional community that doing ecology at the start of the project, even if it's an extra cost, or perceived as an extra cost, is worth it. So definitely a plea for doing it at the start. And if we don't do it, a bit like CDM, a bit like the Health and Safety at Work Act, if we don't do ecology, we're probably going to be breaching some piece of legislation. We've got ecologists in Rail, we've got ecologists, I'm sure, in most organisations. So please do ecology, and it helps protect the environment, obviously. So we're now into the final stages, I think, of the presentation. I'm quite happy to take questions at the end, as I said, but this is just an example of some of the techniques that we're looking at. So I talked very candidly about the fact that open cut probably isn't viable, probably won't work. So pipe jacking is one of the methods that we're looking at. So effectively pushing the pipe through. Obviously, there's a few risks with this site. We know that the ground is potentially made ground, so it's on side-on ground. So there's potentially engineered fill. Well, when we say engineered fill, perhaps 200 years worth of settlement and consolidation of whatever they dug out the nearest cutting. But yeah, supported backfill above. Obviously, there's bedding for the open cut, but yeah, undisturbed soil is going to be quite a challenge here. So if we go back, you can see right away. I think we're going to have a struggle with pipe jacking. We seem to have got a couple of contractors that are confident, but if anybody knows about pipe jacking or if they've got any more information, I'd be quite happy to talk to you at the end. But I think we're going to struggle with pipe jacking. So horizontal drilling is the other option that we are considering. So at this stage, I must say that we are not focused, or we're not finally agreed on the method for installing this new culvert. We know it can't be open cut unless we have everyone's permission, which is unlikely. I'm not convinced about pipe jacking. Horizontal directional drilling, maybe. It's used a lot in the gas industry and the water main type kind of scenario, but this is a 450 pipe that we're going to have to install. So, don't know. We haven't got to the answer yet. But in terms of next steps, so yeah, we've looked at all of the catchment, we've looked at topography, we've looked at geology, we've looked through the PEA, and again, WSP have helped massively. So just from that initial look, the 450 by 450 box culvert that was beneath the railway when we now built it back in the early 1840s actually turned out to be of the correct size. So looking at all of those other factors, Will and I were quite surprised when the pipe size that we needed turned out to be 450, even with the 1 in 100 and 1 in 200 year flows. So that takes into account climate change as well. So we were quite pleased, quite pleasantly surprised actually that the original is pretty much fit for purpose in terms of size. So it's one they got right. So yeah, as it says there, and I'll repeat it out loud, but me, and I'm here as well. We've collectively forgotten this asset and allowed it to degrade to such an extent that it caused operational delay and a debris flow and earthworks failure. So we often share with pride, we share and we salute all of our good stuff, but it's important to recognise when we don't quite get it right. So the unlocated culvert here is just one of a number that we have. There's a programme of works that we're doing to locate those culverts because the risk that we have at these locations where we have an unlocated culvert, as I've demonstrated, is quite significant. And when it rains, could cause a problem. Ultimately, it might lead to a derailment, might cause a fatal accident. Similar circumstances to Carmont in Stonehaven, very steeply graded ground above the railway, drainage system for the track. A little different, there was some new drainage installed there, and that's for another day. But this is where we are. So we're currently undertaking a couple of topographic surveys. We're doing a validation survey, baseline, and then we've got the Form 1 in with capital delivery. So we are moving at pace with it, but eventually we need to look at trenchless and no-dig technologies, which is going to be quite an exciting area for me. So if anyone knows about horizontal directional drilling or open cut, pipe jacking, then speak to me afterwards. But I think that was it. So just a run through of the debris flow, run through of the unlocated culvert at this site, and yeah, sharing pain so that others may learn from it, sharing some lessons. So I'm happy to open the floor to questions.
Yeah, thank you, Mark. So any questions in the room or online? Nothing in the room.
I've got two questions actually. Yep, thank you. Is it possible? I don't know. Is it possible to line the box stone culverts, or is that only able to do on sort of circular pipes?
So we've looked at that particular point. So it is possible to line square or rectangular box section culverts. The problem is you lose some of the capacity. So the 450 by 450 dimensions that we have, you could insert a smaller, generally circular type pipe, but you'd lose the annulus around the edge. Now you offset some of that by the smoothness of the new liner in terms of your Manning's coefficient of roughness for the liner, but probably not enough to offset. You'd have to, when we looked, I think we ended up, I'll go back to the slide in a minute. I think we worked out we could get something like a 300 mil opening through that existing culvert, but again, it snakes a little bit. So not impossible, and it still might be necessary, but yeah, so it is possible to UV line. We'd have to rerun the calculations of 300 mil pipe as well. And then the second,
there was two, I've forgotten the second one.
You can always come back.
Yeah. Yeah, come back to me.
Yeah. Harry? Talked about, you say this is a problem that goes way beyond just culverts, doesn't it? It's about recorded assets or services. You understand the reasons why this was unrecorded? Is it due to the fact that it's from the paper records era? Do you think now that we've got the digital asset database that things should get better over time?
So a few things. So this was recorded in the structures record, so in CARS, so our civils asset record management system. So it was recorded in the structures dashboard, which is the viewer for it. So it showed the culvert there. It showed obviously the state in which I found it, which was a hole in the ground. Well, that wasn't even a hole in the ground. So we had a record somewhere in that ground of it. In terms of the actual record in the list, which is our drainage asset register, it's only as good as the data we put into it. So yes, probably, in answer to your question, it's a legacy of...
You've got different databases, but they're not all the same source of truth.
Correct. So we are now, since this time, we've done a matching exercise. So we have effectively got every single record from the structures dashboard or CARS, the source system, in Ellipse as a record that's there as a marker. So this would have included it, would have been included at the time. So we would have had a dot on the map to show there was something there to have a look at. It's my team's duty, and it's what we're doing at the moment, going around and finding all of these dots on the map and going, right, okay, what's actually there? So there was one dot on the map here. We've got a head wall, we've got an inflow, we've got a culvert, we've got an outflow. So adding those, so we've got a record of these things in the register, so they're not totally unknown and totally unrecorded, but just we weren't managing it. So things will get better as we do more of that verification, more of the checking, more of the cross-referencing, but it's still a big challenge. And these are known unknowns. These are unmitigated risks because we don't know about some of these.
Are you also looking at the aerial photos of it that you've got and seeing where you've got the stream cross? Because in one of the slides, it seems to get to the railway and stop. Yeah, for example, yeah, that one, where it stops, whereas the one to the left, the culvert, it still shows it flowing past it. So that was my second question. Are you doing that as a desktop exercise to try and do that as well?
Yeah. So in our earthworks team, we've got a layer in our register that's called WORM, which is the water hazard. It's something to do with water it's concentration features effectively. So it's looking at OS mapping and saying, right, there's a channel here, therefore it heads towards a railway. You should expect some risk or some asset or something to be there. So we, in conjunction with the earthworks team, have got quite a big piece of work trying to find out where these risks are. The earthworks guys inspect these particular concentration features or the worm features every year, just to see what's there. We do work closely with them and we do pick up where things are potentially going to be an issue. But again, it's asset management as a whole. You can't do everything all at once. So it's definitely focused on steeply graded catchments. It's looking at very, very clearly defined channels like this. On the Somerset levels, if there's an unlocated culvert, probably the risk to railway stability, embankment stability is probably quite low. Still a risk, but the consequence is quite small. So it really has been focused on, and again, that's why we did the bit of work on the LiDAR, and why we tried to colour these maps in different colours to look at the potential. So the risk is the same here as it is on the Somerset levels, it's just the consequence here is greater. So yeah, looking at steeply graded catchments and land that's much higher than us.
So, yeah, that's fine.
I think you mentioned there was a 5-mile-an-hour speed restriction in place. Are you aware of what the sort of wider implications were for trains passing by? And also, there's a road running in parallel. Was there any impact on that?
So no impact on the road, thankfully. Fine. Just so yeah. So 5 mile an hour on the down lane. The line speed here is only 60 miles an hour. So although that's a 5 mile an hour reduction, so it's a pretty big speed difference. Only really for a couple of days while we cleared up the debris. So for the first 12 months, we had a watch person there every day, monitoring it because we had so much material upstream, so much concern about the site. When we'd excavated this material, we'd found the culvert, we'd cut the hole, we reduced the watchman requirement, but yeah, still a big impact to the operation of the railway. On the road side, no, thankfully, no impact, no delays. Although I didn't show it in the slides, we managed to find the Highways Authority cut into the culvert with a gully. They've obviously had a problem with ponded water on the side of the carriageway, on the eastbound carriageway, and they've cut a gully into the culvert, which has caused a load of stone to drop out the side of the culvert. So I always had a great deal of respect and time for Highways England or National Highways until we found that on the survey, and I went, oh God. So yeah, no impact to the highway, but quite detrimental to Devon and Cornwall, but more globally, in terms of train risk or train delays, quite strong.
Anybody online? No, not at the moment. No. Gary, you've got another question.
I know you can't speak about the specifics of this landowner.
Yeah.
But in general, I'm intrigued to know when you've got an issue like this and that you get a phone call at 3 in the morning that you always dread.
Yeah.
What do you need to go and access third-party line? Do you have any legal powers to do so to make the line safe?
Yeah. So we have emergency powers. So there's a section, I think it's 14 or 15. So it's a Railways Regulation Act, so we do have the ability to go in to be careful. So it's got to be an emergency. It's got to be basically something quite serious. So it's the earthwork has slipped onto the deck and it's blocking the track, or the train's derailed, or there's a retaining wall or bridge has fallen over, for example. So it has to be a proper emergency, not just we didn't bother to plan it, therefore it'll be easy to use an emergency power. You can only use the powers for repairing the bit that's causing the immediate issue. So a good example is the site of Shillingham, where we had an earthworks failure, so west of Plymouth on the M&M2, viaduct, or Ford viaduct, off onto a big cutting slope. We couldn't get access to the land, and we were looking at using emergency powers. We could for a very small section, but it had to literally be, we could only get permission to repair the bit that had failed. We couldn't use the powers to stay on the land for any longer than the repair was needed to be done. And we have to apply in like triplicate to the DFT, the Department for Transport, have to apply to the Secretary of State to use the powers. So no, that there are powers, but they have to be, it has to be very significant. So
They're on the wall marked in case of emergency brake.
yes, there is a emergency button, but it's a very long-winded, no, we don't. So we try to do things through consultation, engagement, liaison. It's cheaper as well.
Last meeting, we had Nick Lake coming to talk to us regarding asset protection. So in terms of drainage, Mark, how do you carry out surveillance, or do you know that adjacent landowners are doing some work that's going to be affecting your drainage? And my question comes from the fact that there was this blue pipe you saw us at the start, and must have been there for quite a while, installed, it seems, on with the railway boundary. You know, how did that happen, and what are we doing to stop it happening again?
So asset protection is a whole other conversation, but there is a value. So in terms of the honest answer is, asset protection can't be everywhere. We don't know everything that's happening adjacent to our railway. As much as I would like to know where a farmer has ploughed the field in the wrong direction and therefore the furrows run towards the railway and we end up with sediment, we just don't know. We do regular boundary inspections, we do regular drainage inspections to try and pick up some of these issues, but in this case, it's definitely a case of, although it looks horrific, and it is, and it doesn't pass any kind of test from an engineering first principles point of view, the two things here is that the landowner was trying to do something in terms of diverting water away. So when we spoke to him, he was trying to stop water going straight out into the track. So when it comes to, was the act deliberate and was it well intentioned? Yes, it was deliberate, but it was well intentioned to try and guide the water away from the structure, because the initial contact, apart from the train driver reporting it, was this: there's a blue pipe, what should I do, or you've got a problem. The other thing to note, which we're currently going through in terms of land and freehold ownership, that blue vault fencing against the down main is Network Rail's legal freehold boundary. So if you go to the land registry today, look at the mileage on this, you'll find that our freehold boundary is literally just underneath that four-top fencing. So at some point in the past, we've sold all of this land. You can see the old fence here. There's just one solitary fence post standing up. That was our previous boundary. A little bit of site history. This used to be clay dry, so it used to be where they unloaded clay and China clay. So there was a level siding here that came off the main line. All of this was sold at some point in the 60s. Don't know when, don't know why. But for some reason, we don't own much of that land. So most of this problem is actually third party. Even though it might appear that it's a Network Rail problem, it's definitely a Network Rail problem. But yeah, there's no easy answer to the asset protection question. Many eyes, inspections, using the data, desk studying, the concentration features, and just diligence, being aware anyone can find a drainage issue and report it. It doesn't have to be drainage.
I take it probably in hindsight that actually that was probably building up on less rainfall previously, but it's never seen as a problem. And then until this day, when it was a lot, and it.
Yep. Yeah, I think so. And the other thing that's probably prevented it from being a big problem in the past is when you look at the, difficult to tell from this model, I know, but in an exceedance event, water coming down here, the ground is just about in the cess graded towards this culvert. So you can see it a little bit in some of the pictures. Water in this pipe is coming down towards the track. Some of it's going into the culvert somehow, but most of the rest of it is going along the cess. So I think probably before we had the actual problem in 2018 when it was noticed and reported, much of the rainfall that we'd had over the last 15, 20, 30 years has been going along the cess and draining to the other culvert. So it's kind of a mitigation, but not really.
Okay, any more questions from the room online? No? Okay. Right, so we're going to close the meeting. So Simon, can we make it to the vote?
Yeah.
Thanks.
Thank you very much, Mark. You negotiated the Astro meeting without Nick creating a question in himself, so that was well done. Yeah, no, thank you very much for stepping in at the last minute. You might realise it was we were trying to get someone else, and that fell through between last meeting and this, and you stepped in greatly last week. So thank you very much. Very interesting presentation. Very much about drainage. I didn't know. I'll agree with you about ground investigation, as many other people who put foundations in the ground at regular intervals. Yeah, very interesting, and unfortunately, probably with climate change, something that we might see a bit more regularly, so very important. So thank you very much for coming, and I'd like everyone to share their appreciation in a normal way.
Okay, thank you.